Hi guys, this is Hemant and today we are going to solve Geeks for Geeks problem of the day. So yeah, split linked list alternatively. Given a singly linked list head, your task is to complete the function alternating split that splits given linked list into two smaller lists. The sublist should be made from alternating elements and you need to maintain relative order. Okay, so this is a very easy problem. All of these statements I will explain you in very simpler way. All you need to do is consider this as a zero based array, zero indexed based array. All you have to do is separate even indices and odd indices. What do you mean by that is, like, let's just say this is 0 1 2 3 4 5, zero based indexing. See, 0 even, 2 even, 4 even. You need to separate all these things, maintaining the relative order without messing up order. So 0 0 0, and then 1 3 and 5. So it's just that in array you might have solved it, separating even indices and odd indices. This is very similar to it, but it's just an linked list representation. So let's just see the time complexities and the expected space complexity. So you can iterate over O of n, and then you can use an auxiliary space of O of n. So what do you think when you first see this problem? See, since it is an easy category problem, they're saying you can use the auxiliary space of O of n because you can create two dummy nodes, even and odd, and then whenever you're at even indices, you can maintain a counter. You can create a new node and put in that node, and then you can continue on. You can separate even and odd and then return it. But in my implementation, what we'll do is, instead of creating new node, okay, creating new nodes every now and then while traversing in zero based odd index or even index, we just manipulate this list itself rather than creating the new node. So auxiliary space will be O of n, we'll be only using few pointers. So that's the thing. So yeah, we'll discuss this problem. So since I've already written it, as you can see, 2 5 8 9 6 and then null. So like I discussed before, we are not going to use any space, meaning we are not going to create the nodes. Okay, we are going to use already given nodes, and then we are going to manipulate within the list, within the head list. Okay, so since I need to keep my first pointer at head because this is a zero based indexing. Okay, and then second at odd indices, that is simply heads next. Okay, so these two are the nodes we are going to return in the end of the linked list. So that's why we shouldn't do any manipulation regarding this first and second. Rather, we need to use two more pointers in order to construct first and construct second. So how are we going to actually achieve it? So let's just say I'm pointing c1 to first and c2 to second. So since we need to do it alternatively, what we can do is, you can see simply C1's next, okay, is C2's next. Yes or no? Yeah. So what we did is we just erased this thing, and then we did this, and then C1 will come to its C1's next. So similarly, what C2 does is C2's next is C1's next. This is C1 and this is C2. Similarly, C1's next is C2's next. Similarly, C2's next will be C1's next. You see, the whole point here is, whenever we are doing alternative ways, we are actually breaking the list, right? See, whenever I did this, right, I broke this pointer, and now you can see we are constructing it even indices 2 5, no sorry, 2 8 and then 9, because we are breaking the links. I hope you're understanding. It's very simple problem. So yeah, the reason why I took one more node is there is an edge case. Okay, see, 1 2 3 4 and 5. In the odd cases it will work, but if let's just say there are even number of nodes, okay, if there are even number of nodes or odd number of nodes, we are going to run till either one C1's next is null or C2's next is null. So we are going to continue further. We'll continue this thing again. Yes, Okay, C1's next is C2 next. C2 will come here. Sorry, C1. One second. Yeah, C1 will come here. This is C2, and C2's next will be null. Okay, see, in the end, any one of them, if its next pointer is null, will stop. This will be C2. But here is the edge case. Why I use this extra two nodes is that I need to show one edge case. See, after breaking all the nodes, if you see here carefully, we broke all the nodes. Okay, now you can see 2, 8, 6 and 7, and also here you can see 5, 9, 3 and then null. But if you see carefully, we haven't broken one more link. See, if one of these nodes, let's just say this C2 is ending null, there is no more next pointers, but you see C1 is still pointing to C2's node. So if you don't break this node, it's not going to be a correct implementation. So in the end, you need to break this node as well, and then you can see 2, 8, 6, 7 and then 5, 9, 3 and then null. So this is pretty much it. This is the very easy implementation. I hope you understood. If you're still kind of seeing this for the first time, I think you need to solve very basic problems regarding linked list, and you will understand manipulating the pointers. So yeah, without in order to make it even better, we'll see the code implementation, and also without breaking this list, right? I will show you without breaking this. I will show you, and then with breaking, I'll show you what difference it actually makes. So there is one more edge case I need to discuss, and that is, see, always there will be one node for sure. Okay. So what if there are two nodes? That means I can only return one node and then other node as null, right? So we need to take care of that as well. If let's just say heads next is null, there is only one node. We have to return, that is head, and of course heads next, which is null. This is the case. And then again, like we discussed in our implementation, we create node first pointing to head. See, once we are coming here, after crossing this, if it never happens, we know that there are at least two nodes. That's why we won't get any null pointer exceptions. Okay, and then like I said, in the end we need to return these nodes, right? First and second, but we shouldn't manipulate these first and second, but instead we need to use two more pointer, which will help in construction of this first and second sublists. So yeah, C1 will be pointing to first, C2 will be pointing to second. Like we discussed, we will go until we hit either one of C1 or C2's next is null. Like we discussed here, if any one of them's next is null, then there is no point. So while C1's next is null or C2's any one of them's next is not existing, then we need to stop it. We are going to stop. So what we did in the implementation, C1's next is C2's next, and then C1 will be C1's next. C1's next is C2's next, and then C1 will go to C1's next. Similarly, C2's next is C1's next, and C2 will go to its C2's next position. See, if I just run this, I think this is pretty much it. But like we said, we did not break C1's link. What happens if you don't break the C1's link? I will just show you guys. Yeah, as you can see this is the last node of the C2, but what? C1's next is still pointing to C2's next. That is the reason why we need to break, like I said here. See, this is pointing, if there is 42, it's still pointing for that particular last node. So we need to break that node. We need to break that particular node. So simply saying C1's next is none. So I think this is pretty much it. There you can see, we'll run for all test cases and see if it works. Okay. Yeah, there you can see passed all test cases like we discussed in the earlier. We are not using any extra space. Why we are not using any extra space? We are not externally creating new nodes, rather we are using the existing pre-existing nodes and just manipulating the pointers. So and then yeah, we need to traverse throughout the linked list in order to get all the nodes. And then I think you pretty much understood the implementation as well. So if you like this video, you can like it, and we'll see you in the next video.